Welcome back to Muddy Math, where we take middle school concepts that feel a little muddy and clear them up. I'm Sam, and today we're going to be talking about double number lines. We can look at some statistics from NBA.com. I chose James Harden from the Houston Rockets. James had 264 field goal attempts during his 11 games in the 2018-2019 playoffs. James the Beard scored 41 3/10% of his field goal attempts. Using this information, how many field goals did James Harden make during the NBA playoffs in 2018-2019? All double number lines have to start at 0, 0 because double number lines can only represent proportional relationships. I know 41.3% is significant because percent means out of 100. The root word cent comes up in words like centennial, which is a 100-year celebration, or cent meaning a penny. I can form a ratio here, 41.3 field goals made out of 100 field goal attempts. 11 games. I don't see any other value in this problem relating to games. 264 field goal attempts. Okay, so I also have another ratio. Out of 264 field goal attempts, he made a certain number of field goals, and this is what I'm looking for. So I have two ratios, one with a missing piece of information, and that's the part. Let's label the top number line field goals made and the bottom number line field goals attempted. I know I can use this double number line because it both starts at 0, 0. If he's attempted 0 field goals, he's made 0. At 100 field goals attempted, we know he will have made 41.3. Now this 0.3 is kind of throwing me off because I can't make 3/10 of a shot. So let's keep going with this because that's the percent we're given. But how can I use this to get to 264 field goals attempted? Now I can expand 264 into expanded form because I know that it is 200 plus 60 plus 4. If he shoots 200 attempts, then he's going to have made 82.6 field goals. We can use this logic to help us get all the way to 264. I could go to 10 and multiply it by 6, or 20 and multiply it by 3. So if he attempted 100 field goals and made 41.3, I just have to move that decimal back one place value because we're dividing by 10. I know that for 10 attempts, he will have made 4 13/100ths of a shot. Pause the video if you want to take a second to attempt writing the field goals made for 20 attempts, and I get 8.26. And it still makes sense because double 10, I get 20, double 4 13/100ths, I get 8 26/100ths. If I multiply 20 by 3, I get 60. I'm going to use that same pattern to multiply 8 26/100ths by 3, and I will get 24 78. I'm going to write that next to 60, as well as fill in what 200 is. So at 200 attempts, he's made 82 6/10 of a goal. Now, all I need is to find 4. Again, here we can use the base 10 number system to our advantage. If I want to find how many baskets he made after 4 attempts, I can use 10 to get to 1. To get from 10 to 1, I'm going to divide by 10. And I want to repeat that structure and divide 4 13/100ths by 10. Again, all I have to do is move that decimal place. So I have 413 thousandths of a basket for every 1 attempt. In this situation, I'm going to double the value I got for 1 field goal attempt. And so I'll get, for 2 field goal attempts, it will be 826 thousandths of a basket. And now I can double that again. So 826 thousandths doubled is 1 652 thousandths. And now we have all of the information we need. Our last step is to add this all together. Press pause on your video to try to find the sum of the field goals made for James Harden. So we have that James Harden made 109 32 thousandths of a shot out of 264. Now again, we still have that weird decimal. How could he make 32 thousandths of a shot? When you go to NBA.com, you'll see that James Harden actually made 109. And when you take this fraction and turn it into a decimal, it is about 41.3%. But it is not precisely 41.3%. The decimal actually goes on and on and on. So since they rounded this percent to the tenths place, it threw off the precision of this whole process. But you can see that we are not off by much. If you calculate the percent error, which is a 7th grade skill, you'll see that we are only 0.03% off. Thank you for tuning in. Please hit the subscribe button. Don't forget to like the video and ring that bell if you want to know when new videos are posted from Muddy Math.